Let's take a plot here and see if we can figure out what the underlying equation is that produced it. Now note here I used a minus sign. I can use plus or minus. It doesn't keep you from getting an answer. The only real difference has to do with the sign of phi. So why is that the case? Well, let's say I had something like this. 5 minus 2, which is equal to 3. Well, I could also write 5 plus minus 2 equals 3, right? So if I said find 5 minus x, find the x that makes this true, or 5 plus x that makes this true, just change this to sign. That's all it's going to matter. And this will be a little bit easier in terms of what we're going to do in a moment. All right? So let's take what we already know. So I look at this and say, okay, my upper bound is 4. So here's my max amplitude. Amplitude is equal to 4. My minimum amplitude is minus 2. So if I look at the difference, I have 4 minus a minus 2 is equal to 6. So that's the entire range. And remember that A1 simply scales the cosine. So when A1 is equal to 1, well then the cosine will range from 1 to minus 1. Here it's ranging, because we have an A0 term, from 4 to minus 2. But ultimately what it's doing to cause it to go up is half of this, and coming down is also half of this. So A1 is going to be 6 divided by 2, which is 3. All right? Now that I know that, and I know my max amplitude is 4, I can say, we'll put it over here, A0 is equal to 4 minus A1. So 4 minus 3 is equal to 1. And once again, that's A0. All right? So I've done that. What about the other terms? Well, my plot starts here, goes up, and at point 2 is when it repeats, right? So remember that the frequency is the number of cycles per second. The period is the length of one cycle. So T is this right here. So T is equal to 0.2. And remember, T is the inverse of the frequency. So now I can rewrite this to get F is equal to 1 divided by 0.2, which is 5. And that's in hertz. So we've got that, got F. Of course, T is whatever time value you put in, so we're not solving for that. But now we need to know what the phase shift is, because clearly this is not just a normal cosine wave. So how do we know how to solve for this? Well, let's think about how cosine works. If I just have normal cosine, where A0 is 0, A1 is 1, for any frequency but no phase shift, it peaks right here. Right, at time equals 0. So that means we have a peak when the value that's inside cosine theta, when theta is 0, I have a peak. So that means when what's inside the parentheses here is equal to 0, it's going to peak. And we can see that's at time equals 0.1. Right? So we know that 2 pi ft minus phi is equal to 0. And here's why I put in the minus sign. So that way when I write phi, I get 2 pi ft. I just make the signs easier. That's all I'm doing. The t that we're using now is the 0.1. So I have this is equal to 2 pi. My frequency is 5. And my time is 0.1. So 2 times 5 is 10. 10 times 0.1 is just 1. So I get my phase shift is pi. So ultimately I have my x of t is equal to 1 plus 3 times cosine of 2 times, I'll write everything out, 2 pi 5t minus that right there. All right. So let's look at the program that generated this and see if that's correct. Just to confirm it's the same thing. There's my plot. Point 1 starts down here, so forth. Say naught is 1, that's what I found. A1 is 3, that's what I found. Frequency is f, that's what I found. And then I happen to write I want the peak time to be 0.3, and for the phase, I have 2 times pi times f times 0.3. So 2 times f, once again, is 10, times 0.3, now is just 3. So I get that the phase is equal to 3 pi. All right. So in my program, we get phi is equal to 3 pi, and my calculation says that phi is equal to 2 pi, or excuse me, just pi. So which one's correct? They're both correct, because what's the difference? 3 pi minus pi is 2 pi. So for every 2 pi radians, you just repeat. That's technically what's happening here. From here to here is 2 pi radians. And from here to here is 2 pi radians. And in fact, if you look here, there's 0.3 is where one of the peaks. So I could have used 0.1, 0.3, 0.5, whatever it be on this side, whatever it be on this side. I could use any of those. Each of those is 2 pi radians apart. So technically my answer is correct. And there's no way to come back later and know which one I happen to use because of the repetition. So here's the process for taking at least a simple sinusoid picture and figuring out what produced it, given the values we had.